Here we go. I'm going to start recording now. All right. First thing we should do is we should measure out all the magnitudes of these vectors. So vector A, B, and C. And when I measure out these magnitude for vector A, I get like 3.1 centimeters for vector A. All right. Again, you might have like 3.2 or 3.3 depending on which file you print it out from. All right. And then for vector B, the magnitude of that, I got 4.2 centimeters. Okay, 4.2 centimeters. Again, you might have like 4.4 or things like that. All right. And then vector C, I got 6.5 centimeters for vector C. All right. Vector C looks like it's slightly off the origin. All right. So I got 6.5 centimeters for vector C. All right. Now let's measure the angles for three vectors. Need my protractor. Let's see. I can't see my protractor anywhere. Okay. Okay. Let's see. Oh, here it is. So if I were to place my protractor on the origin, and if I were to take a look at my vector A, it looks like it is directly on it looks like it's on 320. Okay, it looks dead on 320. So 320 degrees is from my vector A. And my vector B, it looks like 56.5. It's slightly more than 56.56 and slightly less than 57. So I'm going to go with 56.5. Okay. So 56.5 degrees. And for my vector C, I got 163, right? 163 on the dot, looks like. All right, 163. Again, you may have slightly different measurements than I do, but I'm just showing you how to do these. So your vector A will have theta, right? So this is the theta A. Okay. And this is your theta B right here. This is your theta B. And your theta C would be this. Okay, that's your theta C. So now what I want you to do is I want you to figure out the components of A, B, and C. So figure out, calculate the AX, AY, BX, BY, and CX, CY. So for A vector, I'm going to calculate it right here. So AX is equal to A cosine of theta A. So my AX is equal to 3.1 times cosine of 320 degrees. So my AX comes out to 2.37 centimeters. Now you may have different numbers because this may be different. Now your AY is equal to A times sine of theta A. So your AY is equal to A, which is 3.1, times sine of 320 degrees. So my AY comes out to, I believe, negative 1.99 centimeters. All right. Now, let's calculate bx and by. So here's my bx, my by will be this, right? So bx is equal to b times cosine of theta b. So my bx is equal to 4.2 times cosine of 56.5 degrees. So bx is equal to, when you plug that in, I think you get 2.32 centimeters. And then the by is equal to b times sine of theta b. And my by then is equal to 4.2 times sine of 56.5 degrees. And my by is equal to, I guess, 3.50 centimeters. Is my by. And lastly, let's do C. So my Cx is equal to C times cosine of theta C. So my Cx is equal to, I guess, 6.5 times cosine of 163 degrees. So my Cx comes out to, when you plug it into the calculator, you get negative 6.22 centimeters for Cx. And then for Cy, you get C times sine of theta C. So my Cy is equal to 6.5 times sine of 163. So my Cy is equal to 1.90 centimeters. All right, so we have all that figured out. So now what we're going to do is we will draw these vectors out doing A plus B plus C. Okay, so my A vector will be represented with my aquamarine blue, and my B vector will be my passionate purple, and C vector is environmentally green. All right, and then my resultant will be fire engine red. So let's start with A vector. Now A vector is 3.1 centimeters long at 320 degrees. So first thing I should do is measure out the angle of 320 degrees. The direction is necessary. So 320 degrees is right here. All right, I don't know if you can see that, through 320 degrees, right? So once you measure out that angle of 320 degrees, you need to draw your vector A 3.1 centimeters along that direction. So here, 3.1 centimeters. All right, It looks like 3.1 centimeters. So here is my A vector. And now comes the tricky part. Now I have to measure my B vector, which is 56.5 degrees, from this tip. But it's really hard to get exact because, like, I mean, 56 can be all over the place, right? So I need to draw a little grid line at the tip of my A. And what I'll do is I use my ruler, and as you notice, this vertical reference point of my ruler versus this vertical line on the axis, and I try to make it parallel as possible, right? And then I draw my slight vertical axis that way, grid line, right? Then I use my perpendicular of this, which is like so, and I will draw my horizontal axis using my other protractor, I guess, like so. So now I have this grid line that I could use as a reference to measure out my 56.5 degrees correctly. All right, so 56.5 is right about here. All right, so that's kind of right there. And then I will go 4.2 centimeters along that direction. So 4.2 centimeters from my tip of my A to that direction. So here's my 4.2. Right, 4.2 centimeters. So that's my vector B. Boom. All right. Then again, I need to draw another grid line at the tip of my B. And again, I will do my best to keep. Now sometimes, like, doing the horizontal is easier than vertical. Okay. Then you do the horizontal line, and then you do the vertical line afterwards. So in this case, my horizontal line, I could measure it out with like this reference line versus horizontal axis and so on. So here is my horizontal grid line. Then I use my other one to get my vertical line. Like so. Then measure out 163 degrees from that point. Okay, so here 163. Oops. All right, so 163 would be right there, 163. Then I will draw 6.5 centimeters along that direction. Right? So 6.5 centimeters. In that direction. So that's my vector C. Okay, so here's my 6.5. Then my resultant will be from the origin to the tip of my last vector, which is vector C. So here, I start from the origin, and I'll go So it looks like 3.8 centimeters. So it looks like 3.8 centimeters is my resultant vector r's magnitude, right? So my resultant vector r looks like 3.8 centimeters, okay? And of course this angle here is my theta r, and we need to measure that. So to measure that, again, I place my protractor right at the origin, and I take a look at this. It looks like 114 degrees. Yeah, 114. It looks exactly on 114. All right. So my theta r looks like 114 degrees. All right. So these are measured value. Right? So these are measured value. Let's see what it looks like when we calculate this now. Okay. So here, if we write down the a vector in Cartesian form, we calculated these components already. So ax is 2.37, so positive 2.37 centimeters, and ay is negative 1.99. And then for my b vector, my bx is 2.32 centimeters positive, right? 2.32. And my by is positive 3.50 centimeters in the y direction. And then for my c vector, it looks like negative 6.22, negative 6.22 in the x direction, and 1.90 positive direction for my cy. So when I add all these up, I should get my, Rx and then Ry respectively, okay? So when I add all these up, I think I get negative 1.53 centimeters x hat and positive 3.41 centimeters y hat. And that makes sense. Look, it looks like 1.53 and then 3.41. All right, so this is the Cartesian form of my resultant vector calculated. Then if I want to find the magnitude of that resultant vector, right, all I have to do is use the Pythagorean Theorem and use 1.53 squared plus 3.41 squared. I've noticed people actually use negative in here and they forgot to square the negative and get a positive out of it. And they got a hypotenuse less than some of the side's length. And they just wrote that down as an answer. And that just broke my heart on the quiz. All right, so please, let's think that through. So the magnitude for that comes out to 3.74 centimeters if you calculate that correctly. And this is the magnitude. It's pretty close, 3.8, 3.74, right? We're half a millimeter off, right? So that's what we have. Now, we need to calculate theta r. To do that, we should calculate this beta r first. Now, this beta is in second quadrant, and so is my r. R is in second quadrant. So it has to be 180 minus the absolute value of your beta r. So your beta r should come out to negative because it's tan inverse of, right, ry over rx. Therefore, my beta r is equal to tan inverse of ry, which is 3.41, over Rx, which is negative 1.53. So my beta R comes out to negative 65.8 degrees. Now, because it is in second quadrant, my theta R, right, is going to be 180 degrees minus the absolute value of your beta R, right? Therefore, my theta R is equal to 180 degrees minus the absolute value of negative 65.8 degrees. So my theta R comes out to 114.2 degrees. So that's pretty good. That was good drawing. So I got 114 here and 114.2. All right. Any questions? All right. Some people got confused in your quiz. When you get this actual angle, like they added it to 180 instead of subtracting it. So be careful. All right. All right. I'll let you absorb that for about a minute or two. Let's move on to page 18. Okay. Now we will use the same values that we got here. Okay, you can use your value. However, for page 18, we have different operation. Instead of a plus b plus c, for page 18, we have b minus a minus a minus c. Okay, so you're going to use this. Okay, so for my resultant vector r, it is equal to b plus, okay, b plus negative a plus negative c. All right, so that's the operation we're going to be doing for your next addition. Okay, so b is okay. I mean, like we just have to get the b out from here and then place it like that. But the negative a has to be same magnitude, but in the opposite direction of this a. So it's going to have to go, right, flipped, going this way. That's my negative a. So since this is 320 degrees, if I subtract 180, that's the direction for my negative a vector. Okay, so when I subtract 180, I think I get 140. Okay, so when I get 140, so measure 140 from the positive x, and that will give you a negative a. So I will let you work on this. I'll give you about 8 minutes. See if you can draw this thing out and show me what it looks like. All right, so here we go. So we're going to start out with b, and when we see my b vector, it looks like it's 56.5 degrees and then 4.2 centimeters. So first I need to measure out, all right, my 56.5 degrees first. So I will do this and then find 56.5 degrees, which is right around there, I guess. Yeah, due to the parallax, you could see it's slightly like 56. Yeah, so 56.5 degrees. And then draw 4.2 centimeters along that direction, right? So 4.2 centimeters along that direction. So 4.2 centimeters. So here is my vector B. Okay? Now, from my vector B tip, I need another vertical and horizontal grid line so that I can measure my angle for my negative A. All right, so here, I'm going to do my best to get my vertical lines lined up and then draw my grid line. Okay, and then I need my perpendicular here, horizontal. So from this grid line, I will measure out my negative A. Remember, because my A is 320, my negative A would be 140 going in the opposite way. So this would be 140, and my negative A would be 3.1 centimeters along that direction. So I measure out 140 degrees first. So here's, oops, so 140 degrees. So 140 degrees right there, looks like 140 degrees. And then I will be going 3.1 centimeters along that direction. So 3.1 centimeters in that direction. Oops. 3.1. So that's my vector negative A vector. And then from that tip of my A, I will have to draw out another grid line. Okay. And then negative C. Since my C vector is 163, if I add 180 to that, I get 343, right? 343. So 180 plus 163 would be 343. So I would have to measure out 343 degrees. Oops. Sorry. 343 degrees. 330, 340, 343 will be here. Or maybe I should go up a little higher. Right, 343. Again, this is probably parallax of. So 343 will be like one more degree up higher. All right, that's 343. All right. So I will be going along that direction 6.5 centimeters. So 6.5 centimeters along that direction. Right, so here, .5 centimeters along that direction. Voila. So this is my negative C. Now, my resultant will be from the origin to the tip of my C. So my resultant will be from the origin to tip of my C. And that looks like 7.1, maybe a little more than 7.1, but definitely less than 7.2. So I'm going to split the difference. I'm going to say 7.15 as my resultant vector's magnitude. Okay, so here, my resultant vector here is that. And the magnitude of my resultant looks like 7.15 centimeters. All right, so that's what I measured. So let's, yeah, 7.15 centimeters. All right, so here, now we can measure the theta r. And theta r can be measured I see 30 degrees, right? I see 30 degrees right on the dot right there. Yeah, 30 degrees? Yeah. So my theta r looks like 30 degrees. That means these are the measured values. Let's see how good we got. Let's see how well we drew this thing. And this is the measured, right? Now here, what I'm going to do is I'm going to blacken out these. And then I'm going to actually write down B first. And then I'm going to say minus A. And then minus C for my third vector. So my B vector, we said it was 2.32, right, for the x, and 3.5 for the y, right? And then for my a, negative a, since my a here is positive 2.37, my negative a will be then negative 2.37. And since my AY is negative 1.99, my negative A would be positive 1.99. And then for negative C, since it is negative 6.22, my negative C would be then positive 6.22. And my CY, since it's positive 1.9, since it's negative C, it is negative 1.90. Therefore, when I calculate all this out, this should be my Rx, and when this would be my Ry. Okay? So, when we work it out, I get 6.17 for my Rx, it's positive, and here I get 3.59 for my Ry, and that makes sense because it's Rx, Ry, and it's the first quadrant, they're both positives. 6.17, that looks a lot longer than this, which is 3.59. So yeah, it looks good. So this is my Cartesian form of my resultant vector calculated. Then the magnitude of my r is equal to square root of 6.17 squared plus 3.59 squared. And if you work that out, oh, look at that. You get 7.14 centimeters as your magnitude. That's pretty darn close. Then your theta r is your beta r because it's in first quadrant, which is then tan inverse of, right, ry over rx. Therefore, your theta r is equal to tan inverse of 3.59 over 6.17. And that comes out to 30.2 degrees. Wow, that's again very good. So my resultant vector in polar coordinate system or polar form would be 7.14 centimeters, comma theta is equal to 30.2 degrees. So that was drawn very nicely. All right, that was drawn very nicely. All right. Any questions? All righty. I'll let you. All right, page 19. Now we have to measure all these out, just like what we did previously. Okay. Now again, I'm going to be measuring my vectors here. It might be slightly different for your drawings, but the methods are going to be the same, right? So let's take a look at my A vector. For my A vector, I get 3.6 centimeters for my A vector. You may have slightly longer version, depending on which file you printed out. And my B vector looks like I get 4.55. It's a little less than 4.6, but definitely more than 4.5. I'm going to split the difference, and I'm going to say 4.55 centimeters. And then, for my C vector, it looks like I got 7.6 centimeters on the dot. All right, so 7.6 centimeters. Now again, you might have slightly different measurements. All right, now let's measure the angles. For my A vector, it looks like I have 200. Let's see. I see 214 degrees for my A vector. All right. So 214 degrees for my A vector. And my B vector, it looks like 112. Yeah, 112, right on the dot. Okay. And my C vector, drop my pen. My C vector looks like 17 degrees right on the dot. All right. So that's what I got. Now here's what you need to do. You need to figure out all the AX, AY, BX, BY, CX, CY, and calculate it right along the side right here. Okay? So, let's see. Here, AX is equal to A times cosine of theta A. So, AX is equal to 3.6 times cosine of 214 degrees. And if you plug that into your calculator, I believe you get negative 2.98 centimeters. And then AY is equal to A times sine of theta A. Therefore, AY is equal to 3.6 times sine of 214 degrees. Therefore, your AY is equal to, if you work it out in your calculator, I believe you get negative 2.01 centimeters. Then, your BX is equal to B times cosine of theta B, and that is Bx is equal to 4.55 times cosine of 112. So your Bx is equal to negative 1.70 centimeters. Then your By is equal to B sine of theta B. Therefore, your By is equal to 4.55 sine of 112. So your By is equal to 4.22 centimeters. Then your Cx is equal to C times cosine of theta C, and your Cx is equal to 7.6 times cosine of 17 degrees, and your Cx is equal to 7.23 centimeters. Then your Cy is equal to C times sine of theta C. And your Cy is equal to 7.6 times sine of 17 degrees. Therefore, your Cy comes out to 2.22 centimeters. So now you have all the ingredients for your calculations in component form. All right. I guess we can fill these in. So A is negative 2.98 x hat, and then negative 2.01 y hat. And for B, it is negative 1.70 x hat and positive 4.22 y hat. And for C, it's 7.23 x hat and 2.22 y hat. So for the resultant, I think you should get like 2.55 x hat and 4.43 y hat. But we'll check that later after we draw this thing out. All right. So first, let's draw out the A. Right. So it's A plus B plus C. Right. So first, A vector is 214 degrees. Right. So let's measure out 214 degrees. Where your positive x-axis is 0 degrees. Right. And then 214. And that is 210, 214 is right here. All right, that's 214. So we will, no, it's not. That's like way off. Oh, okay, now it's, okay, I guess it was moved. All right, so 214, it's still there. All right, so here, now I will go 3.6 centimeters along that direction. So 3.6 centimeters. .6 centimeters, and here's your A vector. Okay. Now I will need a grid line from that tip of A, right? So I'm going to do my best to create a horizontal line with my ruler so that it is okay. It looks about parallel. Yeah. It looks about parallel right there, huh? So, oops. When that happens, look at that line. That's so bad. Then, let's do the vertical line. Okay, so if we were to do a vertical line, so that looks like a vertical line right there. Now I will measure for my B 112 degrees from that crosshair. So 112 is 110, 112 is right here. Okay, I don't know if you can see that 112. Maybe it's slightly off. Parallax. Alright, so 112. Okay, 112. And then my B vector is 4.55 centimeters along that direction. Okay, so 4.55 centimeters along that direction. Along that direction. That made it a little long. I drew 4.65, so 4.55 should be right here. Alright. So, again, if I were to draw my horizontal and vertical axis at the tip, here's my horizontal line. Remember, I drew that little long, so I cut it off a bit. Then my vertical. So here, I'm going to draw my vector C from this, and it is 17 degrees. 17 degrees, which is right there. 17 degrees. And then I will go 7.6 centimeters. .6 centimeters along that direction. So 7.6. That's about 7.6, right? And here is my vector C. This is my vector B. So my resultant will be from the origin to so it looks like about 5.15 5, it looks like 5.15 centimeters along that direction here. So here's my resultant. This is my resultant. And my resultant magnitude looks like 5.15 centimeters. Again, that's measured. And this here is my angle theta r. If we were to measure that, I get like 60 degrees on the dot. Like 60 degrees on the dot. So my theta r is 60 degrees. So these are again measured, okay? All right. So if we were to calculate this, my resultant magnitude comes out square root of, right, 2.55 squared plus 4.43 squared, and I get 5.11 centimeters, which is pretty darn good. All right. And the theta r is equal to tan inverse of, right, 4.43 over 2.55, and that comes out to 60.1 degrees, which is again pretty darn good. That's a pretty good drawing that we did, or at least I did. Anyway, any questions? So I will leave it up here for a while, okay? And we have 12 minutes, so maybe 15, 18 minutes. Yeah, we have plenty of time. So here's what's happening. I would like you to now show me that you know what you're doing. And this is your quiz, page 20 and page 21. All right, will be your quiz. All you have to do is draw these out. So this is worth 10 points, this is worth 10 points, this is worth 10 points, and this is worth 10 points. Okay? So I'll give you till like end of the day. So hopefully by like midnight you should be able to upload this. Catherine, you have a question? No, ry over rx. For theta? For b? Okay. It's still ry over rx. It would always be ry over rx. For beta too, even for beta. Always ry over rx. And then you will get, if it's in second quadrant, your beta will come out to be negative, but you would subtract that negative, the absolute value of that negative, from 180. And if it's in third quadrant, your beta will come out to be positive, and you just add 180 to that positive beta. Fourth quadrant, you can leave it as negative angle, or 360 minus the absolute value of your beta. All right? Yeah, so that's very important. I think if you guys check your quiz, I think I graded it and I put comments down. So some of you actually missed a few points because your angles were off a bit. But take a look at your quiz; it's already graded. So if there's no question, any other questions? Yeah, I'll let you start. I'll let you start now, and then hopefully by the end of the period, you have at least the first part done. Make sure you have this. Now be careful because this thing is, see this is for A, it is 18 degrees up from negative x-axis. So it's 18 degrees up from negative x-axis. So it's in second quadrant for A. Okay, so I'm just giving you that heads up. Theta and beta, okay? This beta here, C, is 20 degrees down from the positive x-axis. So this way, all right? So this is in fourth quadrant. So be careful. All right, so get to work. I'll stop the recording here.